Hey, hello viewers. Welcome once again to the Mickey Maths class, a channel dedicated to demystifying mathematics, making complex things easy. Alright, today quickly we'll be examining prime factors. But before we delve into what prime factors are, we have to have an understanding of two things: prime numbers and factors. So the first one, factors. What are factors? Factors are whole numbers that divide another number without leaving a remainder. That means the factor of a number is that number that will divide it without leaving a remainder. How do I mean? For example, if I'm asked to list the factors of 12, what does it mean? That means I should mention the numbers that will divide 12 without leaving a remainder. First example of factors of 12, you have 1. 1 can divide 12 without a remainder. 1 can divide any other number you can think of. 1 will divide 12 to give me 12. 1 will divide any number to give you the number itself. Another factor of 12 is 2. 2 will divide 12 to give me 6. That means 6 is also a factor of 2. Now 3 also will divide 12 to give me 4. That means 3 is a factor of 12. 4 is a factor of 12. And like I mentioned earlier, 6 is a factor of 12. 6 will divide 12 to give me 2. And lastly, 12 will divide itself to give me 1. That means every number is a factor of itself. 12 is a factor of 12. If I'm having a number like 14, that means 14 is a factor of 12. So every number has a minimum of 2 factors. 1 and that number itself. That leads us to the next thing, prime numbers. Prime numbers are numbers that have just 2 factors, itself and 1. That means no other number can divide them. That means the only number that can divide them is 1 and itself. Examples of prime numbers, you have numbers like, examples like 2. Only 2 can divide 2 and only 1 can divide 2. You have 3. You have 5, you have 7. These are examples of prime numbers. They have only 2 factors. Now, someone is asking me now, what of 1? 1 is not a prime number. That's why a lot of students make mistakes. So take note, 1 is not a prime number. 1 has only 1 factor, that's itself. And the condition we mentioned for a number to be listed as a prime number is that it must have 2 factors. 1 has only 1 factor, which is itself. So 1 does not qualify to be a prime number. 1 is not a prime number. These are, you can have other examples like 11, 13, 17, and so on and so forth. Now, having understood these 2 key terms, we examine what prime factors are. Prime factors are factors of a number that are prime numbers. How do we mean? Let me give you a practical example. For example, I have 12, and like we listed earlier, the factors of 12: 1, 2, 3, 4, 6, and 12. Now, when you say list the prime factors of 12, amongst these factors, which of them is a prime number? Now, we have concluded, or we have reached a conclusion that 1 is not a prime number, so we do not choose it. 2 is a prime number, so we separate it out. 3 is a prime number also. That means 2 and 3 are prime factors of 12. The other numbers don't qualify to be prime factors of 12. So the prime factors of 12 are 2 and of 12 are 2 and 3. Another example, for example, I can choose a number 18. 18, the prime factors or the factors of 18, let's list it out. 18, you have 1 times 18. You have 2 times 9. Can 3 times anything go? Yes. 3 times 6 will give me 18. 3 times 6. 4 times anything give me 18. No. 5? No. So I read it downwards, upwards. So the factors of 18 will be 1, 2, 3, 6, 9, and 18. These are the factors of 18. Now let us identify which of them are prime numbers. 2 and 3. The others are not prime numbers. So that means 2 and 3 are prime factors of the number 18. You can also have other examples like 15. You have 3 and 5 as prime factors of 15. 3 and 5 being prime factors of 15. So prime factor of a number are those factors that are prime numbers. That means those numbers that can divide that number and are also prime numbers. Now, let's take an example. In some scenarios, you could be asked, express the following numbers. The following numbers as product of 8 prime factors. A question can be given like this. Express the following numbers. Let's see, 24. Let's take this one, 90. You can be asked to express 24, 90 as product of its prime factor. Some question might say, okay, leave your answer in index form. Let me add it. Leaving your answer in index form. Okay, 24, we can have two methods of solving it. You can use what they call the factor tree, or you can use what they call successive division by prime numbers. I will use the two methods here. So the first method I can use, let me use the factor tree, 24. So I put my 24 here, then I begin to break it down. 24 can be gotten as what two numbers can I multiply to give me 24? I can have 2 times 12. That's 2 times 12. Now 2 is a prime number, so I circle it. But 12 is not a prime number, so I need to still break down this 12. I will break down 12 to give me 2 times 6. 2 times 6. Now we are gradually coasting home. The 2 here is also a prime number, so I circle it out. But 6 is not a prime number, so I cannot use it. I need to still break it down as product of prime number, which is 2 times 3. 2 times 3. Now I have every of the number now broken down as prime numbers, product of prime numbers. 2 and 3. So 2 here, 2 here, 2 here, 3 here. I've ended up using the factor tree to express 24 as a product of these prime factors. So I'll put 24 will be equal to 2 times 2 times 2 times 3. This is what to do when you are asked to express a number as a product of its prime factors. 2 times 2, 4. 4 times 2, 8. 8 times 3, 24. All the numbers that are multiplying are prime numbers. Now, the second method you can use, let me use it, the second method for this, 90. The second method you can use is by using successive division by prime number. The first prime number is 2. So let's use 2 to divide. 2 in 90, that will give us what? 45. 2 in 90 will give us 45. But I cannot use 2 again. So I go to the next prime number to use because 2 will not divide 45. Now 3. 3 will divide 45. This is how to know if 3 can divide any number. When you add the number together, if the number is a multiple of 3, yes, the 2 can divide. What do I mean? 3 can divide it. 4 plus 5, 9. 3 can divide 9. So 3 can also divide 45. So 3 in 45, you have 15. Let's test again. 5 plus 1, you have 6. 3 can divide 6. That means 3 can divide 15. 3 in 15, 5. Now we got into this point, 3 cannot divide 5. We go to the next prime number. The next prime number is what? 5. 5 in 5, 1. We are left with 1. We have ended up breaking down the 90 up to 1. Now the next thing, 90 will now be 2 times 3 times 3 times 5. So we have ended up breaking down 90 or expressing it as a product of its prime factors. Now, yes, I almost forgot something, but look at this one. Leaving your answer in index form. Now this is 24, is 2 times 2 times 2 times 3. Now how many 2 did we see here? 3. That means this is 2 raised to power 3 times 3. That's in index form. How many 3 am I seeing? 1. So that's 3 raised to power 1, or you leave it as 3. It's still the same thing. Now this one, 90 is 2 times 3 times 3 times 5. I have only 1 2. So this is 2. How many 3 do I have here? 1, 2. That means 3 raised to power 2. How many 5 do I have here? Just 1 5. That's times 5. So I've ended up leaving it in index form. Alright, you can try out this one. You can take it home. Take home fun. Take home fun. You can do it at your leisure time. Express the following numbers as product of its prime factors. You can also leave your answer in index form. Okay, let's look at 100 and use 100, 2, 18, 3, 48, and 4, 49. So express these numbers as product of its prime factors 100, 18, 48, 49 as a product of its prime factors. Don't forget, leave your answer in index form. Thank you for listening. I hope you have learned a lot today. Remain blessed till I meet or we meet again next time. Keep practicing. Mathematics is fun. Stay blessed.